Hi, my name is Stuart Lynch, and this is the second video in the Realm and SwiftUI series. And this is actually the second part of using the ObserveResults to build a ToDo app. In this video, you'll be introduced to Realm Studio so that you can see your Realm data in a GUI interface. We'll also complete our application by introducing the Observed Realm Object Property Wrapper, along with completing our CRUD operations for updating and deleting objects from our to-do list. In addition, we'll learn about SortDescripters for sorting your results, and I'll introduce you to a searchable function for filtering the results in the list. This video is sponsored by AppFigures. AppFigures makes tracking the business side of your apps like downloads and revenue a breeze, while also helping you to grow your downloads with very intuitive tools for App Store optimization and for competitive intelligence. And it's not just the tools. Ariel from AppFigures shares guides, tutorials, and even hosts live streams to teach you how to promote your app. I also recommend checking out his YouTube channel for weekly news about apps. AppFigures helps you spend less time tracking and more time developing. Sign up with my code, Stuart3030, to get 30% off your first 3 months. Links are in the description below. Thanks again to AppFigures for sponsoring this video. I love getting your feedback, so tap the thumbs up button if you enjoyed this video and leave a comment below. Make sure you subscribe to the video and ring that bell to get notifications of new videos. And if you want to support my work, you can buy me a coffee. This is a continuation from the first video in this series, so if you haven't completed that video, I suggest you do it so that you have a starting point for your project. A link is in the description below. If you choose not to, however, I also have provided a link to the completed project from that first video if you want to download and use it. When we run our application from part 1, we'll see that we have some to-dos that have been persisted. But where's that data and how can I take a look at it? Well, it turns out that by default, Realm stores the data locally in your Documents directory. So I want to be able to take a look at that file. So open the entry point for your app, that's the one marked with @main, and create an onAppear function where the window group presents the to-do list view. Inside there, we'll print out the Documents directory path to the console. And this could be done using the File Manager, Default, URLs for the Document directory in the user domain mask, and we'll choose the first one and we'll force unwrap that, and then specify its path. And also, while we're at it, because we were using a navigation view in SwiftUI, I'm getting these nonsensical constraint errors in the console, and I want to suppress these. And because I do this almost all the time, I've created a code snippet for it, and I suggest that you do the same. You can see that it's using user default standard, where we'll set a value of false for the key _UI constraint based layout log unsatisfiable. Now, when we run the application, those constraint errors are no longer. But you do get to see the path for the document folder. So we can right-click on this and from the Services menu, choose Open, and then Run the service, and that will open the Documents folder where you can see the file titled default.realm. Now, in order to view that file, we'll need the free Realm Studio application. And I already have it installed, but you can download it from here. And I'll leave a link in the notes below. Follow the link to install Realm Studio and download the DMG for macOS to open it. And then all you'll have to do is drag it into your application folder. And I suggest that you launch it at least once first. If you open the app, you'll see Open the Realm file, but better than that, we can just double-click on our Realm file, and that will open it. Note that it's displaying the To-Do class on the left, showing our 2 entries. And each entry has our 3 properties: the ID, which is the object ID, the name, which is a string, completed, which is a bool, defaulting at false, and urgency, which is defaulted to a 1. And it's using that raw value for our default neutral urgency enum. Now here's the really great thing. Let's go back to run the app one more time, and I'll minimize Xcode so that we can see both the simulator and Realm Studio on the same screen. Now I've connected the hardware keyboard now, so you won't see the keyboard pop up. But we know that it dismisses when we enter a new to-do. So let's create a new to-do now in the simulator. And if I add it, we'll see that it immediately gets added to the Realm. And we see it directly in the Realm Studio app. If we're in the Realm Studio app, if we update one of our items, like we can do here, we see that it gets updated in our app directly. That's perfect. It's a live object. Let's use the Studio app to create a new to-do. See how that new item gets added to our list in our simulator as well? This is fantastic for testing. The next step then is to look at how we can do these updates from the app beyond just creating new to-dos. I want to be able to do more with our list row. I want to be able to display the rest of our properties, and I want to be able to update directly within that list row. So for that, I want to create a new SwiftUI view. So we'll create a new group by selecting the to-do list view and then creating a new group with that selection that I'll call views. So within there, I'm going to create a new SwiftUI file that I'll call to-do list row. So we're going to pass in that iterated task, but we're going to be able to observe changes on that, just like we do with bindings, because each row iteration is one of the items in the observed results. So we can use the observed realm object property wrapper to declare our variable that it will be a to-do object. And now we can actually use our canvas by passing in a to-do instance to our provider. So this is what we want our rows to look like. And we'll want to make every one of these components editable. I.e., if we tap on the checkbox, it'll toggle. We'll be able to update the to-do text. And if we tap on the urgency button, it's going to cycle through the different values and change color. So let's design this to-do row. Let's start with the checkbox. Well, this can simply be a button that displays a different SF symbol depending on whether or not the to-do item is completed or not. So I'm going to start by creating an H stack. And within that H stack, I'll create a button with an image as a label. Notice I'm using snippets. I use the same syntax all the time. So I have snippets that allow me to quickly create buttons with text labels or buttons with image labels. So the image here is simply going to be the system name that we can use a ternary operator on based on the current value of the to-dos completed property. So we'll set it to a checkmark.circle if it's true, or just a circle if it's false. And then for the action, we can toggle the to-dos completed property, but we'll have to toggle the wrapped value. Also, we'll need to designate the button as being a plain button style. Otherwise, when we tap on the row, the entire row will be selected, and we only want it to be targeted to this button. The second item is our to-do, and for that name, we can just bind a text field, which is the to-do's name property, to that text field. So for our placeholder, we'll use an update to-do, and then we'll bind it to the to-do's name property using the $sign as the binding. We'll set the text field style to rounded border. And then add a spacer so that we can have our urgency button on the right. But first we're going to have to do a little more work for the urgency button. So I'll return to our model, and then I'll add another computed property for our enum, and that I'll call color. That will return a color. Now that's a SwiftUI view, so we'll have to import SwiftUI instead of Foundation. So next I'll switch on self and then just return a different color for each of the three cases. So I'll use teal for trivial, secondary for neutral, and red for urgent. We'll also need a function that will cycle through the different options when we tap on our button. So we can create a function or another computed property for this directly in our model. So let's create a function, and I'll call it increment, that returns a new urgency. So we'll switch on the instance urgency property, and if it's trivial, we'll move to the next level and return neutral. If it's neutral, we'll move up and make it urgent. And then if it's urgent, we'll cycle back to being trivial. So we can return now to the to-do list row, and we'll create a new button. This time we'll use a text view for the label, another snippet. And it'll just be the to-do's urgency.text value. We'll add some padding of 5. And I'll add a frame that sets them all to be a width of 80, regardless of which urgency it is. I'll set the foreground color to be a color that is the system background. And then for the background, I'm going to create a rounded rectangle with a corner radius of 10. And then I'm going to add a fill that is our to-do's urgency.color, that computed property. And then once again, we'll have to set this button style to plain. And then we'll add some horizontal padding to the entire stack. For the action, we'll need to update our to-do's urgency property, and we'll use the wrap value by calling that to-do's increment function. If we return now to the to-do list view, we can change the for each loop to use the to-do list row, passing in that iterated to-do. Let's run this now in our simulator and make some edits. We can check some off or edit some to-dos and change the urgency. You choose what you want to do. Let's stop and rerun the app, and we see that our changes have persisted. Well, this is taking care of updates. What about deleting a to-do? Well, it turns out that this is incredibly easy. All we have to do is execute an onDelete on the iterated row for our for each loop. We'll know that the index path is, because we're within a loop, so what we can do is simply call the ObserveResults remove method, and that will remove and update the item from our list. Let's just test this once more. First, we'll add a new to-do, make sure that it still works, and we can update in line as we see before. But I don't want to have a drink anymore, so let's delete that to-do. Perfect. That was simple. What I prefer to do is to have all of my completed to-dos at the bottom of the list as they all get checked off. Now this requires a sorting of our results, and there are a couple of ways to do this. I can do it as I fetch the results, and therefore the results when updated will always be sorted when the view gets rebuilt. So let's try that first. We can add another argument to our ObserveResults property wrapper called SortDescriptor. And this is a sort descriptor that'll take in a key path, and that's the string representation of the property name. So in our case, that is the completed property, And we could also specify that we want it to be ascending, so we could say true, or descending, which case we'd say false. But since the default is true, we don't even need that. Let's test and run the app now, and we'll see that all of our checked items are at the bottom of the list. As we check them off or uncheck them, our view adjusts accordingly. And I have a big problem with this. It's not smooth. I'd like to have some animation. And the problem is that it's updating before the view is presented. So there's no way that I can animate the changes in this list as is. So the solution is to move that sorting out of the property wrapper and put it within our for each loop. And then I can animate the changes. So on our to-dos, we'll apply the sorted by key path function. And this time we'll just specify the key path as that string. And since the ascending is true by default, we don't need to add that. And with that in place now, we can use the animation function on our entire V stack using the default animation. And we'll watch for changes on the entire to-do results. Let's test again. That's much nicer. What if we want to do multiple sorts? What if we want to sort by urgency as well as completed? Meaning that within our incomplete items, it'll be sorted by urgency, and our completed items will be sorted by urgency. We can do that too, but this time we'll need to use sorted by and not key path. And this will allow us to pass in an array of sort descriptors. So the first will be a sort descriptor where the key path is our completed property, with the default ascending being true. And the second will be our urgency key path, and we want it to be sorted by urgency, which is the integer 2, down to trivial, which is at 0. So urgency is on top, we'll need to set the ascending to false. Let's test this. That's looking pretty good. But there is a problem, and I mean a really big problem. Let me delete this buy groceries item. What happened? Wash dishes was deleted instead of get groceries. And it deletes the wrong item because the delete is based on the actual results order, not for this for each loop sort. So the problem that I've encountered at the moment is that you can't call the delete function on a sorted for each loop like this. You'll have to either do it without the animation and do the sorting in the original fetch, as we did first, or you'll have to wait until the next video where I show you how you can solve this problem. I like the animation, so I'm going to keep it here, and you'll have to watch the next series of videos where I show you how you can manage this dilemma. In the meantime, then, you should probably comment out this line of code for deletion. Well, I could stop here, but there's one more feature I want to show you, and that's the ability to add a filter to the list so that we can filter by task name. First, we'll need a string state property for our search bar that you can use to filter on, and we'll make it an empty string initially. Next, we can attach a searchable function to our list, and there are a number of options to choose from, but the one that I want is the one that is the searchable with the text, collection, key path, and suggestion, where that last term is a view that presents the filtered items. Let me organize this a little bit better. Now, our text is bound to our search filter property. The collection is bound to our to-dos collection. And the key path this time uses the standard key path syntax instead of the string. So it's just \name. For the suggestions now, we have a new array of to-dos. So we can create another for each loop, iterating over those to-dos, presenting the name as a text view. Then we can apply the search completion function on that to-do name to associate a full string with a row view that is within a search suggestions list context. That is the list row view, so that when we tap on it, we'll present that list row. So let's test. With this in place, we can tap into the search field, and then as I start to type, the list filters based on that string matches. For example, if I start typing the letter B, both the to-dos for the birthday and for making the beds are displayed because both contain the letter B. As soon as I type the letter E, the list filters more to display the make all of the beds item. I can then tap on that item and edit it in place. I haven't actually made the beds yet, and it is an urgent matter. Now, I could do more searches and edits, but let me cancel out of the search. And I see that my edits have been saved and updated. Well, that's a great start to using Realm for SwiftUI, but there's still much more to do. In the next project, we'll be adding in a one-to-many relationship to our model, where the property in the model links to a list of objects from another model. And this is a typical scenario in a more complex application. And we'll also fix that delete issue. So make sure you subscribe to my channel to get notifications of new videos.